So today we're picking up on something that we did last spring. Remember those logic things where we rewrote the if-thens and we checked, sometimes you had to write what's a valid conclusion. Sometimes we gave you the full argument and you had to say, does that one work or not? Kind of, sort of remember that? We're going to review that and build on that. There's another kind of argument that works that we did not talk about last spring. It's going to be totally new. And now that we're in Algebra 3, not Algebra 2, we have to give reasons for our answers. If it works, what's the reason? If it doesn't work, what's the reason for that? So we're building on what you learned last year, some review, some new stuff. Starting with some vocabulary, we talked last spring about syllogisms. These were formal logic, and there were 3 statements altogether, two that come first, and then a therefore conclusion to make up an argument. I want to remind you, some of the ones we saw last year seemed kind of silly. We are simply evaluating, is this good logic or not? It is not, does this make sense here on planet Earth? Some of these, imagine you've been transported to some other planet or some alternate reality, and things aren't as we know them, but logic still works the same way. We're just saying, does it follow the rules of logic or not? That is all we evaluate with these. Our first sentence we called a major premise, and that was the one that we had you last spring always rewrite as if something, then something else. Sometimes they were already in that form. Sometimes you had to rewrite it and put in those 2 words, if and then. Minor premise was the second statement, and then conclusion was the final one. What we wanted to see happening was we asked, does this match the if? And then a valid conclusion. If the second one matches the if, a valid conclusion had to match the then part. And that is the only kind of logic we talked about last spring. And we'll review that with some examples. Students who had me last year saw this notation already. The conclusion, therefore, something or other. Sometimes therefore is kind of a lot of writing, and I get tired of writing it over and over. It is okay to use as a standard math abbreviation 3 dots arranged like the corners of an equilateral triangle. And so I just put that up there for that to possibly help you guys out. Do I need to wait, or are we okay? Don't see anybody waving at me. So we had an example kind of like this. So just reviewing last spring, if we started off with all men are mortal, who could tell me how we would think of that as an if-then statement? What does that mean in terms of if and then? Lucy? Okay, so, or if someone is a man, then that person is a mortal. And then Aristotle is a man. Does that match the if? So far so good from what we did last spring. Therefore, Aristotle is mortal. Does that match the then? And so therefore, last year we would have said that that is valid because it follows the pattern of our original sentence that we have. Probably don't want to write all of this out, but another way of saying that is the major premise many times identifies a group, men, and then a property of that being mortal. And one valid argument would be to follow that same pattern. The minor premise would have to match the group, identifying somebody that's in the group, and then the conclusion would have to match the characteristic of that. So What we learned last year and what we're going to continue to do is we have an original conditional statement. If then, whether it's written like that or not, we can convert it to that. Shorthand way of writing this to kind of keep track of it, and we'll use this in our formula list in a few minutes to write these down, these four types of arguments down with a little bit shorter form. Many times we'll let P represent the content of the if. So if I've got, if whatever that is the P, then whatever else comes next. Instead of even writing the words, we can do it even shorter with an arrow. If P, then Q. So let me give you what might be an original conditional statement. And this is one that I think probably makes sense here on planet Earth, so we don't have to imagine that alternate reality just to try to make sense of what I'm going to say. But if you get 95% on every single homework paper, and you get 95% on every single test, every single quiz this semester, then your grade would be an A for the semester grade. That makes sense here on this planet? So we can go along with that. So let me make up a name. Let's see, there's nobody in here named Sebastian. So if Sebastian gets a 95% on every homework, so a 9.5 out of 10 on every single one, hadn't happened, but if that did, then Sebastian has an A for the semester grade. That matches that argument, right? Yes? So we would say that is a valid argument. Whatever the original conditional is, we're going to assume is true. If not here on Earth, then on some other planet somewhere. Okay, the other one that is going to be a valid argument is going to have a really long name, contrapositive. It is going to switch the ifs and the thens, and it is going to put not in each of those two clauses. It's going to put nots in and switch the order. So our original one was if P, then Q. The contrapositive is not a squiggle, Q, then an arrow, not P. So to take the contrapositive of getting 95s on everything, then an A. The contrapositive is going to be if not an A, then not 95s on absolutely everything in the grade book. Does that make sense here on our planet? If you don't end up with an A, then you didn't have a 95 on everything. There was at least one thing you didn't have a 95 on. Does that make sense to you? If you don't have an A, there was at least one thing that didn't have a 95. In fact, it would have to have way lower than a 95, like maybe a 20 or 30% on a test or something like that to pull that average down. That also makes sense to us. That one is also good logic, valid logic. Those are the two that are going to be good logic, valid arguments, matching the original pattern or matching the contrapositive, switching the order and putting knots in on both of them. But we also need some reasons for the ones that don't work. One of the ones that does not work is called the inverse. It puts the knots in, but still keeps the same P first and then the Q. So we started with if P, then Q. The inverse, same order, P first, but it's not P, then not Q. We started off with if 95s, then an A. So this is going to be if not 95s, then not an A. Is that the way it's supposed to work here? How many of you would like this? How many of you don't want it to work like that? If you don't get a 95 on every homework, raise your hand if you've forgotten a paperback that does not have a 9.5 on it. Better be absolutely everybody, because I haven't given out any half points yet. So you want it to be, okay, can't get an A. Do you want it to follow this pattern? So this one does not work. It is not good logic to argue like that. So we're not saying true or false, but we're going to say not valid or invalid. And the last one with a name is called the converse. and it does the other thing. It changes the order, but forgets to put in the knots. So we started with P, then Q. The converse is Q, then P. And so if I took the converse of my original, if 95's then an A, my converse is just going to change the order. If A, then 95's. If you get an A at the end of the semester, then that means you had a 95 on absolutely everything. Has anybody ever gotten an A and everything in Infinite Campus has been a 95%? Most of us have, some 92s and some 99s and, throw in, an 85, but we had enough 99s that made up for that and we still got the A, right? So this is also not good logic. It is not valid. Now, those were a lot of words, so let's do a shorter form in your formula list for easy reference while you're learning these names, and you can easily look it up and see what the reason is for it. So I did a heading without a formula number and a lesson number on it. If we're starting with the original condition, conditional, P then Q, anything else that matches that pattern is valid. The contrapositive is also valid. And so that would be not Q, then not P. Change the order and put in the knots. If we had P, then Q, and that was good, then the inverse would just put in the knots, not P, then not Q. And the converse doesn't put the knots in, it only changes the order, and it's not valid. So now we need a way to remember these and keep these straight. You guys do whatever's going to work for you, but here's what works for me. I don't have any trouble remembering from last spring. If it matches, if it's the same order as the original, then we're good. And I can remember that means it matches the original. Contrapositive has the most letters in it. It changes the most things. It changes the knots and the order. And it's the other one that's valid. The last two are the ones I have trouble with. Converse has an O in it, and it changes only the order. Inverse does not have an O in it, so it does not change the order. It just puts in the knots. Use that if it helps you. If something else helps you more to keep straight which is which, you're welcome to use that. And now we're going to move on to examples and practicing identifying what all of this means. So if we had all rabbits are fast runners, sometimes the book will say write it as a conditional, write it in if-then form, so you need to write it out, but you at least want to think what's the if and what's the then. So I need somebody to suggest how we might write this in if-then form. Thank you, Una. If it's a rabbit, then it's a fast runner. If an animal's a rabbit, then it's a fast runner. Sometimes we call the if part hypothesis and the other part conclusion. So let's see if we can come up with a valid argument that says, if it's a rabbit, then it's a fast runner. Jack is a rabbit, therefore. Who wants to try to give me a valid argument? It's got to either match the original order or match the contrapositive. Those are going to be the only two valid ones that we do. What does Jack is a rabbit match, if or then? Here is our if. Here is our then. Jack is a rabbit. Does that match the if or the then? The then. Okay. Oh, no, we're not. We're just saying, does that match the if or the then? The if. This is what we did last year. That matches the if, so that lines up with a P. We need something that would match what? P, also match P, match Q, match not P, match not Q. To be valid, if we've matched the if, what does the next part have to match? What next? The Q. So it needs to match being a fast runner, so give me a valid conclusion. Therefore, Jack is a fast runner. that would match the original, and that would be what we'd put down as the reason. So if the book said all rabbits are fast runners, Jack is a rabbit, therefore Jack is a fast runner, we would say valid because it follows the original. Okay, what if the book had, if it's a rabbit, then it's a fast runner. Next was Peter is a slow runner. Can we come up with a valid conclusion for that? Is this one like last year, or is this one of the other ones that we've talked about that can be new? What are you thinking, Addie? Therefore, Peter is not a rabbit. Perfect. Because Peter being a slow runner is not Q. So if we've got the not from the original then, the only other valid one is the not of the original if, which was being a rabbit. So therefore, Peter's not a rabbit. So we would say valid because it follows the contrapositive. That is the not P. Kind of starting to see what we're doing with these. Going to do a couple more. All frogs are green. We need to figure out what's if and what's then for that. So Julia, would you give me an if-then form of that sentence? So if it's a frog, then it's green. Henry is a frog. What does that match? We've got P here, Q here. Henry being a frog, does that match P or Q or not P or not Q? Nitsa, what do you think? If P's a frog, Q's green, Henry being a frog, is that P or Q, not P or not Q? So that is P. So what would a valid conclusion have to match? P, Q, not P, not Q. Everybody. It would have to match Q. So how would we write that in words to match the Q? Anugia? Say a little louder. So therefore, Henry is green. And that would be because it follows the original. Back of the book will only say valid or invalid. Here at this school, we expect the reasons. Okay. Still, if it's a frog, then it's green. P is frog, Q is green. Thomas is not green. Allison, what does that match? P, Q, not P, not Q. Well, just the Thomas is not green. Don't try to fit, yes, but backing up to the steps. Not being green, is that P or Q, not P or not Q? That one is not Q, so the conclusion that works has to be not P, and Allison also said that that meant, therefore, Thomas is not a frog, and that one is valid because it follows the contrapositive. Okay. We need to figure out, is this one valid or invalid, and give a reason. All normal dogs have 4 legs. We need to figure out what's P and what's Q. If we wrote that in if-then form, what would that look like, Carson? If it's a normal dog, so that would be P, then it has 4 legs, so that would be Q. 4 legs. Is that the same as P, the same as Q, the same as not P, or the same as not Q? Everybody, 4 legs. That's just Q. There's no not in it. Is there a valid argument that starts with Q? Got to be P then Q, or not Q then not P. So we know that's invalid. Let's take a look at, though, at dog being normal. Is that P or Q, not P or not Q? That's P. What pattern went Q then P? What pattern just changed the order? Everybody. So we would write invalid Converse, even if the book just says invalid in the back of the book. Okay, if-then form. You're going to have some of these in your homework. How would we write that in if-then form? And this is not true on my planet Earth, but wherever I am, this is a valid statement. I'm just going to check the logic on this thing. Addie? Okay, if an animal's a chicken, then it has 3 legs. So being a chicken is the P, having 3 legs is the Q. So we wrote it in if-then form. Now we need to just write with words the contrapositive. If, what, then what. Who wants to give that a try? You want to try that, Lucy? Everybody kind of starting to get the hang of these? Okay, last one. Here's all 3 sentences. The book will do that a bunch of the time and ask you valid or invalid, and you also have to give a reason. So all non-athletes are vegetarians. If we did that in if-then form, what would that one look like if we started doing that in if-then form? Alex? If someone's a non-athlete, so that's our P, then that person is vegetarian, that's Q. Okay, now we have non-vegetarian. Is that the same as P? Is that the same as Q? Is that the same as not P? Same as not Q. So everybody's saying that's a not Q. So valid then has to be not P, not non-athlete. Jim is an athlete. Is that a not non-athlete? Get those double negatives in, and then we're going to clean up the English here and just say Jim is an athlete. So that is indeed not P. So valid. And which one was that? What's the name of that pattern? That's the contrapositive. Last thing I'm going to put up, if I were you guys, I would not do all of this writing because I think you've got everything except the very last sentence already in your formula page where you wrote it in a much more concise form of what all the different possibilities are. The one I want to point out to you, there's at least one problem coming up in one of the sets that is going to be invalid, none of the above. It doesn't follow any of our patterns. Maybe it's a P, then not Q, or something strange like that. So your possibilities are going to be valid follows original, valid follows contrapositive, invalid inverse, invalid converse. E would be invalid, none of the above. That will be a possibility. Anybody with questions?